Hello, welcome to Dr.K.Liu Math channel. This is an example about the line integration over a vector field. And here, this is a vector field. And we call that a line integral over vector field is integral along the path. And this is the curve put inside the vector field and times d differentiating the path. In other format, we can write this as like this. Alpine t. This is dot dt. Okay. This example will demonstrate two different paths on the effect of the different path to the line integral over a vector field. First, the vector field is fxy equal to y minus x, comma x in two-dimensional. This is the vector field. The blue arrow is the vector field of the function f xy equal to y minus x, comma x. Actually, vector field is a function in if vector field in two-dimensional space is a function from two-dimensional space to two-dimensional space. And here, and from the point 0, 1 to q, 0, 1 is here, this one, p, this is p, 2, 1, 0, along the quarter circle. Quarter circle means this circle. First, we have to calculate along this. First, we have to calculate the path of the equation of this path. In 3D, the equation of the path is equal to R1. I call that R1. And the better way is to has first point is 0. 0, I suppose that the angle is 0. Then I suppose psi t. Should be psi. Psi t, cosine t, and then t from t from 0 to pi over 2. You can check that. If you put 0 into the function, psi 0 is equal to 0. When t equal to 0, the point R0 is equal to 0.1, which actually is the p. When t equal to pi over 2, then the point is equal to 1, 0. You can put this. Therefore, we calculate that the line integral over vector field is equal to, I calculate here, part A, C, the interval is from 0 to pi over 2. The function is can be put this point into this function. Therefore, the first part is cosine t minus sine t, comma sine t. Then the differentiate the derivative of the path is equal to cosine sine minus sine dt. And using the dot product, we have cosine squared t minus cosine t sine t plus or minus sine squared t, because here we have minus sine dt. And then this cosine squared t minus sine squared t is equal to cosine 2t. Cosine t sine t is equal to 1 over sine 2t. The first one is 1 over 2 sine 2t. The second one is 1 over 4 cosine 2t. Put the value into the function 1 over 2 sine pi minus 1 over 4 cosine pi minus 1 over 2, 0, minus 1 over 4, this is 1. Sine pi is 0, cosine 1 over cosine pi is minus 1, this is 1 over 4, plus 1 over 4, this is 1 over 2. Please remember, this is 1 over 4. And then I use another path, this C2, R2. Actually, the C2 is from this point to this point. Reverse the path of the direction of the path. Therefore, we here the R1, R2 should be equal to cosine t sine t. Here, the question also gives the path, the name of the path. I just put all the stuff into the formula here. Okay, for B part, R2 pi t equal to R2 equal to cosine t sine t. If the f function is equal to y minus x comma x. And differentiate the path is equal to minus sine t cosine t. The interval is from 0 to pi over 2. Here the function should be sine t minus cosine t. And comma and cosine t. This is f that put the function into the put the curve into the function and dot this vector, the derivative of the path bt, and multiply. The dot product is equal to minus sine squared t plus cosine t sine t plus cosine squared t dt. This two part is equal to minus cosine 2t. This part is equal to 1 over 2 sine 2t. 1 over 2 sine 2t plus minus 1 over 4 cosine 2t. Put the m2 point into the function. The first one is 0 minus 1 over 4 cosine pi let me check. Sorry. This is positive because I make a mistake here. Cosine square minus sine square is equal to yeah. And then I found what is mistake here. Oh, I made mistake in the previous one. Okay, this plus. Therefore, this is minus 1 over 2. The previous the answer of in part A should be minus 1 over 2. I make a great mistake here. Okay, and then I continue this equation. Put 0 into here is equal to minus 0. Yeah, this is 1 over 2. Why I taught this two example. Yeah, two example I point out one very important message to all guys. If we integrate line integration along a vector field, over a vector field along a path, which is actually quite depends on the direction of the path. In this direction, we can see we calculate that it's minus sign. Once we reverse the direction, the result is positive. Therefore, sometimes we will use this one. Which is equal to minus c. This I have to remind you that integration, the line integral over a vector field or over a function, which can be positive or negative once you are along a curve or reverse the curve. This is important. This is the message of this video. Okay. I hope that I will not make you confusing because I make a serious mistake here. Okay, but anyway, hope guys can enjoy this video. Bye bye.